Hi viewers, this is Sri Ramalu. So before watching this video, please subscribe my YouTube channel, that is s.s space physics. So today's topic is thermodynamic scale of temperature. We know that different thermometers used for measuring temperature depends on the property of the thermometric substance. Okay, so there are the many thermometers are there in this world, right, to measure the temperature of the substance. But here these thermometers depends upon the nature of the substance or property of the substance, right? Suppose if you want to measure the temperature of the human body, then we have to use Fahrenheit. If you want to measure the temperature of substance, then we use Celsius or Kelvin. Okay, so like this, different types of we have. Hence, such a thermometric scale cannot be absolute. Kelvin constructed a temperature scale which is independent of nature of the working substance. Right? So, according to him, according to Kelvin, what he did, he measured, he calculated, hence see here once again. Hence, such thermometric scale cannot be absolute. So there are the many are there, but they are not exactly measurable thermometers. So here Kelvin he constructed. So he prepared one new scale that cannot depends upon the working substance. So that is independent on working substance, means it cannot depends upon the substance. Okay. So but above all are depends upon the substance only. But Kelvin what he constructed that it cannot depends upon the working substance. He used the property of Carnot heat engine that its efficiency is independent of the nature of the working substance and is only depends upon the temperature of the source and sink. Yes, according to Carnot, what is his efficiency of any heat engine is what? It is equal to always 1 minus T2 by T1. Am I right? Okay. So efficiency depends upon the temperatures only, not depends upon the working substance or nature of the working substance. It is independent. Yes, what he said above, it is independent. So efficiency depends only on temperatures of sink and source only. Okay, so next he showed that this thermodynamic scale of temperature agrees with the perfect gas. Perfect gas is also called as ideal gas. Okay, perfect gas is also called as ideal gas. Okay friends, don't forget that is also ideal gas. Consider a reversible Carnot heat engine in which Q1 amount of heat is absorbed from the source at higher temperature theta1 and a Q2 amount of heat is rejected to the sink at a lower temperature theta. Here what I am doing here, theta 1 theta 2 not shows the angles, these shows the temperatures, and theta 1 shows the temperature of the source. Okay, temperature of source, and theta 2 shows the temperature of the sink. Okay, and q1 is heat energy given by the source, q2 is heat energy absorbed by the sink. Okay, like this. The remaining heat is converted into work, then efficiency of heat engine is given by. So what, how does it works, heat cannot heat engine, it works, it take the heat energy from the source, certain amount of heat energy take from the source, and utilizes only part of heat energy into work. Heat working substance receives the heat energy from the source and convert the part of heat energy into work, and the remaining heat energy give to the sink. Okay, so like this it takes from the source and it gives to the sink. So in this manner so engine works. Okay, so then its efficiency can be written as efficiency is equals to 1 minus q2 by q1. So that is, it is in terms of q only, in terms of heat only, right? So in terms of not I'm not taking in temperatures, I'm taking only in terms of heat. The efficiency depends upon the temperature T1 and theta 2, theta 1 and theta 2. That is, efficiency is a function of theta 1 and theta 2. As the temperature changes, then efficiency also changes. So it is not only in this formula. One more formula for this efficiency is theta T2 by T1. So T2 by T1. Okay. Or here theta 2 by theta 1. Why? Because theta 1 theta 2 are given as taken as temperatures. Now, so that is why it is a function. So efficiency is a function of what? It is function of temperatures only. So that is why I'm writing it is f of theta 1 and theta 2. So why? Because here q1 q2 is there. So that is why it is f of theta 1 theta 2. And from this bring this is this side and function this side, then for this positive function this side it becomes negative, and this negative q2 by q1 become positive. Okay. Now next one. And then here, now here what is it has? It is q2 by q1. If you write q1 by q2, it comes downside, means in denominator. While taking reciprocal, then it becomes in denominator. And let me take this whole function as capital F. That is also in terms of theta 1 and theta 2. Similarly, if there is another Carnot heat engine which works in between the temperatures theta 2 and theta 3. So this one working in between what? Theta 1 and theta 2. But here condition is what? Theta 1 is greater than theta 2. So that is why this function is written like this. Okay. So this above function is written like this. And suppose if there is a one more Carnot heat engine and which works in between the temperature theta 2 and theta 3, and the condition is this one, means this higher temperature and is a lower temperature, then we can write like this is also okay. When theta 1 theta 2 are there, then heat q1 by q2. If theta 2 theta 3 are there, then heat q2 by q3. Okay, right? How it is in order, same, right? It is also in order. So let it is equation 1 and it is equation 2. Next, similarly, if there is a third one, right? It is the first one. It is the first one, and this is second one. Let me take one more Carnot heat engine, and which works in between the Q1 and Q3, and the condition is what? Sorry, theta 1, theta 3, and condition is what? Theta 1 is greater than theta 3. Then Q1 is a heat. It is a Q1 is a heat absorbed by the engine at a temperature theta 1, and Q2 is the amount of heat rejected at a temperature T2. Then it is also a function of theta 1 and theta 3. So that is a f of theta 1 theta 3. So 1 3 is there, then write 1 by 3. Okay. So how we have written here, in the same manner we will write third one also. Now what I am doing, let multiplying equation 1 and 2. So let me multiply these two equations. Okay. And our left side terms are multiply left side, and right side term multiplied right side only. So like this I have multiplied. Now here these two gets cancelled. Now it becomes q1 by q3. So q1 by q3 is also function of theta 2, sorry, theta 1 theta 3. So that is from the equation 3. It is not from equation 1, it is from equation 3. So right, equation 3. So equation 3 is what it is giving. Q1 by q3 becomes, it is f of theta 1 theta 3. So that is why f of theta 1 theta 3 is taken. Since LHS of above equation does not contain theta 2. Yes, LHS left side, see 1 node 3 is there. So hence it is possible only if function f is of the form. So which form here, see, is of the form f of theta 1 comma theta 2. I am taking one more functions here, phi of theta 1 by phi of theta 2. So f of theta 1 by theta 1 theta 2, I am writing it as a 1 by 2, and f of theta 2 theta 3, it is 2 by 3, where pi is the other function. Multiplying equation 4 and a 5. So let me multiply these two. This side will be multiplied, and these two also multiplied this side, and then here these two again get cancelled. Phi of theta 1 by phi of theta 3, and it is written as like this. And this is also may have the one more function, that is also like this, f of theta 1 and theta 2. Okay. So f of theta 1 theta 2, f of theta 1 theta 3, it is f of theta 1 theta 2 into f of theta 2 theta 3 is equals to f of theta 1 theta 3. So it is equal the both sides. So already we proved. So once again it is proved. So from equation 4 and 1, it is a fourth equation, and first equation is there, where see it is a first equation. So this is a first equation. Okay, then so in the first if you compare those two equations, then q1 by q2 is equals to phi of theta 1 by phi of theta 2. Since q1 is greater than q2, therefore phi of theta 2 is greater than theta 2, phi of theta 2, it provides what it gives: theta 2 is always greater than theta 1 is always greater than theta 2. So from these we can understand like this. Okay friends. Next, hence the function phi of theta increases with increasing theta. As this value increases, then function is also increases. Hence, it can be used to measure the temperature. So, like this, we can measure the temperature. Let us denote phi of theta by the temperature tau. Okay, let me use one more quantity, one more term. In terms of this phi of theta 1 as a tau 1, q2 in terms of phi of theta 2 is a tau 2. And in terms of efficiency on thermodynamic scale of a scale, efficiency of reversible Carnot heat engine. So Carnot heat engine also written like this: eta is equals to 1 minus q2 by q1. Q2 here, when 2 is there, tau 2, 1 is there, tau 1, but tau 2 q2 is equals to tau 2, q1 is equals to tau 1. So okay friends, so finally it can be written as in terms of tau also. Eta is equals to 1 minus q2 by q1 is equals to 1 minus g2 by tau 2 by tau 1. So this is the temperature measurement formula or efficiency measurement formula. So this is the thermodynamic scale of temperature. Okay friends, thank you.